Hi there retro computer fans. In front of you we got a Z80 breadboard computer. Yeah, the Z80 CPU was one of the main players in the late 70s, early 80s. You'd have come across that little puppy and the ZX Spectrum, Commodore 64, Amstrad, and also it used to be using a lot of industrial control gear back in the day. It was quite a beast back in the day, but most of you youngsters nowadays would just laugh at it. But yeah, so I got it all exploded out onto a breadboard. So basically we got a minimalistic breadboard computer. So I've got a display interface. I built a display interface there just so I could see what's going on in the data bus and the memory address bus. And also the control lines such as machine, the machine cycle, read, write, I/O and memory. So at the moment you can see it's reading from memory. Look at reading the bottom half. So yeah, so basically we got the Z80 CPU. We got a UART serial interface chip, just so I can link it up to my computer and look at it through serial, such as using PuTTY or Teraterm. Yeah, that is the 6850. So we got our ROM, got 256k ROM, which is 250. It's 32 kilobytes actually of memory, and again with the RAM we got another 32 kilobytes of memory, and just a bit of memory logic, glue logic at the top there. So at the moment I'm running the Microsoft Basic image on there. I've got it configured so we're using the first 8k of ROM, so that's like 0 to 1FFF in hexadecimal, and the rest is for the RAM. You'll just see the Z80 it's got 15 bits of 16 bits of address space and 8-bit data bus, all parallel, sort of parallel data shifting. And these are all old chips and all work quite nice actually together. So I just thought I'd do a video just to show you this beast. At the moment I'm actually generating a clock pulse from my wave generator. I'm only running at 19.2 kilohertz. I think that chip is designed. We could actually run that 8 megahertz, but that's just a bit silly on a breadboard. And another reason why I've only run it at a slow clock speed, just so I can see what's happening on the data and address bus while while it's busy. So at the moment you can see it's doing a little bit of memory access, as you can tell with the 16th bit, so and 15th bit really, so it's starting from 0. So I've got that tied to into an inverter, just so we can get memory access from that bit. Anyway, so this is Microsoft Basic 4.7. That's 1978 vintage by Microsoft. So what I want to demonstrate is I've got a little program copied into clipboard. I just wanted to show you youngsters what is actually going on when you so do a copy and a paste onto your screen. You just think it's instantaneous, but it's not. So that's copied into the clipboard. So if I paste that now, you'll see it doesn't just paste automatically. It's actually the processor's having to think about it before it. So it's doing the first line, then it's doing the second, thinking about it, which it's done. So if I press enter now and run the program, basically this is just going to put a random pattern on the screen. Let's see if it does it. So it's definitely thinking about it. See, we're reading from memory right into RAM, and the I/O access will be when it's grabbing information from the screen, or actually transmitting to the screen. So you can see now that it's doing it very, very slow. So basically all we're doing there with the code is we're taking the char value 206, and then we're just doing like a random kind of random picture going on the screen or something. Anyway, so that's it. Yeah, it's quite satisfying sitting here watching it do its thing at this speed. You can drop it down to 110 baud, I believe, on Teraterm, because whatever my clock frequency is, the UART chip does share it, but it divides it down into 64, and that'll give you your baud rate that it's actually transmitting at. So, you know, like 19,200 divided into 64 is about 300 baud. So there you have it. I'm probably going to leave it on the breadboard, so I think it's quite good educational sort of thing. So my son is just in secondary school now, and he enjoys computer science stroke IT. You know, I think it's probably a good way to show him how computers work, basically, rather than giving him an Arduino and just telling him to just go online and copy a load of libraries and then just print it out and sit there and watch it and think to yourself, how does that work? But there you go. So basically on that breadboard, it's contained into this Atmel chip, but this has got more in it. It's got more peripherals such as PWM, SPI, UART, it's got all sorts of different peripherals on the Arduino. But this one here, basically the only peripheral it's got is this, which is the serial interface. So even in that laptop there, this is the same principle here. You've got a processor, peripherals, RAM, ROM, and that's just a bit of glue logic. But basically you've got the same. You've got the processor, RAM, ROM, peripherals such as the keyboard, and anything else that you plug into it will be classed as a peripheral. So there you have it. That is the Z80 breadboard computer. So it's still processing. So there you go. Just so you can have a look at the chips, just so if you want to do something similar. Don't think you can see that one, but that is an Atmel job. Can't remember the actual chip. You said I'll find it before I go. Yeah, it's an AT28C256. It's the ROM, static RAM. It was originally designed to work with dynamic RAM, but why bother with dynamic when you can have static? So there you go.